Hi guys, it's Sandmit Gaikwad. I'm gonna show you guys, take you guys through like a lecture for interpolation because I didn't really explain it that well on the last meeting we had. So first I'm gonna show you how to derive this. If you don't want to look at that, you can just skip past it. Then I'm gonna show you how the StellarXplorers video, how they got their formula because it's from the same formula that I'm about to derive. And then we're gonna do practice problems, just two, like very, very short ones. One where it's just like the single interpolation, where, okay, we have the table and we know that one of the values is, like, it's gonna be exactly one of these, but maybe the inclination is, different. And then one where we don't know both of them, like we have to interpolate twice or like 3 times technically. So let's just start. We're just gonna call this linear interpolation notes lecture, whatever. So first, the basic concept of interpolation is that you have a line and you have 2 points on that line, but the point that you want to find is in between those 2 points. So let's just draw that. So this is going to be y, this is going to be x, and you have a line, and on it you have some x high value and some y high value, and then you also have some x low value and some y low value. And somewhere on this line exists a point that we want to find. So we're going to call that x desired and y desired. Okay, so I'm going to take a different colored pen and I'm just going to draw the lines for this. So here you see that we have a triangle. Well, the leg or the height of this triangle this way is y high minus y low, and then the x length of this triangle is x high minus x low. Okay, so that's one part of it. Now, how do we apply that to find the desired value? Well, we can just draw another smaller triangle, right? And these are going to be similar triangles because they're from the same, well, they obviously have 90 degrees if you're dropping in altitude. And then they have the same internal angles because it's the same triangle, just scaled down. So, hopefully you understand the geometry there. But then here, it's going to be xd minus xl. And for the height, it's going to be yd minus yl. Okay, so the relationship here is that we have this and this over is equal to this and that, okay, because that's just similar triangles, it's pretty basic stuff. So we have yh minus yl over xh minus xl is equal to yd minus yl over xd minus xl. Okay, so this is the general formula. Okay, this is the general formula. Now, how do we get from here to the StellarXplorers girls formula? Well, let's just say, okay, I don't want to look over every single time. I want to be efficient, right? I want to get all my y stuff down on one side and all my x stuff down on one side. So that way, if I'm looking at this graph, I don't have to keep hopping between like this side and this side in the same one expression. I want to get everything y on one side and everything x on one side. So what we can do, I'm going to rewrite this. I want to have all my x's in a group and all my y's in a group. So it's going to be like this. I want to get this down here and this up here. So what I'm going to do is I'm going to multiply by 1 over yd minus yl on both sides. And remember, y is just well, technically this is a subscript, you know, the d and the l. It's not like you're multiplying stuff, so don't think you can just like factor out y or whatever. Don't be silly. So that's gonna make this go away, and then I want to get this on this side, so I'm gonna multiply by xh minus xl on both sides. Whoops. Sorry, my hand hit the thing. Okay. So that's there. So then this and this will cancel out. Okay. Let me zoom in. Yeah, perfect. Okay, so you see that. And, well, what does that simplify to? So we just have yh minus yl over yd minus yl is equal to xh minus xl over xd minus xl. The StellarXplorers girl's formula was basically the same thing, but like she had, well, okay, if we raise both of these, if we just take the reciprocal of them, we're gonna get yd minus yl over yh minus yl is equal to xd minus xl over xh minus xl. Okay, that's basically the same as her formula of target minus lower bound over upper bound minus lower bound. Whoops. Okay, equals target minus lower bound over upper bound minus lower bound. Okay, so that's literally, oh my gosh. That's literally the same exact formula, and we got it from this one, okay? So that's hers. Now that you know that, let's just do a practice problem to see if we understand what's happening. Okay, so looking at here, we're gonna do one problem. Okay. One problem where we're gonna keep something constant. Okay, so let's just say we're gonna keep the altitude constant. So this is our altitude, right? And this is our inclination. So we'll keep our altitude constant. We'll say let's do 1500. Okay, we'll keep our altitude constant at 1500 for this first example, and I want our inclination to be we'll do in between 35 and 45. We'll just do like 42, or actually 43. We'll do 43. Okay, so let's do that. It's going to be in between these two, so it's going to be 1500, and it's going to be in between 35 and 45, so that's going to bring us down to these two values. Okay, so our practice is going to be 43 degrees inclination and 1500 kilometers altitude. Okay, so what do we do now? We need to have our x inclination and our y be mass, because changing the inclination is going to change our mass. So this is the independent variable and this is the dependent variable. Now, looking at our formula, what do we need? We need high, low, and desired value for both of these. So our x high, looking at this graph, our x high is 45. Our x low is 35, and our x desired is 43. So I'm going to write that down. 45, x low is 35, and our x desired is 43. Now for y, our y high corresponds to whatever x high was. So it's not whichever number here is bigger, it's what corresponds to the higher inclination value. So the value for mass at 45 degrees inclination at 1500 is 1356 kilograms. 1356 kilograms. Then the other one is going to be 1465 for our low value. And we don't know what this is going to be. We just don't know what it is. So let's just plug all this in to this formula and see what we get. Well, we know that we need to solve for y desired. So how about we just make it a little bit easier and get y desired by itself already. So using this formula, I'm just going to write it down. So y desired is going to be all of this stuff multiplied by this bottom thing, and you add YL to it. So it's going to be YH minus YL over XH minus XL times XD minus XL, and this is going to be added to YL. Now, plugging all our numbers into a calculator with like subbing this stuff in, we're going to get our y high is 1356, subtract the y low, so it's 1465, and then divide it by the XH minus XL, so it's 45 minus 35, and remember to close the parentheses, and then you multiply this by XD minus XL, so XD is 43 minus XL is 35, and we're just going to add that to YL, which is 1465. So what I got is 1377.8 kilograms. So this is 1377.8 kilograms. Boom, check done. You can do it using her way, my way, or not my way, but like the general way, or her simplified formula. Either of those are fine as long as you know where this came from. Now we'll do a problem where we don't know both, or where the inclination and altitude are both not given on here. So we'll stick with 43 inclination, but let's change our altitude from 1500 and bump it up to like 80, okay? So let's do 1580. So now we're going to be looking at between 1650 and 1500 and between 35 and 45. So we're going to be looking at this box of values now. So I'll change colors just to be nice. So practice with 43 inclination and 15, did I say 80 or 85? I don't remember. Okay, shouldn't make a difference. Okay, I'll let you pause now if you want to try to do it, but I'm gonna do it in 5, 4, 3, 2, 1. Okay, so hopefully you tried it. If not, let's see how to do it. So we're gonna be in between 1500 and 1650, right? So we know that we need to do it for 1500, and we know we need to do it for 1650. Well, 1500 at 43 degrees inclination, we already did it. So I'm just going to put that here. Okay, because we already did it down here, and I don't want to just do extra work for no reason. But here, we don't know what it is. So let's do the same thing that we did here for the 43 inclination and 1500 kilometers, but change it to the 1500 kilometers. Or change 1500 to 1650. Okay, so our x inclination is again just the x high is going to be 45, the x low is going to be 35, and our x desired is going to be 43. Then our y for mass, our y high is going to be, looking at this table, 45 is going to be 1307 kilograms. 35 is going to be 1399 for the low value. And we don't know what this is. So let's just plug it into the formula and do it again. Well, we know the formula down here to find yd, so let's just write that down and do everything. So yd is equal to yh minus yl over xh minus xl multiplied by xd minus xl and added to yl. So plugging in to a calculator, clearing our old work, we should get YH is 1307 minus YL is 1399 equals, and then divided by XH minus XL, which is 45 minus 35, multiplied by the XD minus XL. XD minus XL is 43 minus 35, and we add that to our YL, which is just 1399. And what we get is 1325.4. So we'll call this YD2, and we'll call this top one YD1. So this is YD1, YD2. So we know what this one is, and now we know that this one is 1325.4. So now that we have YD1 as 1377.8 and YD2 as 1325.4, these are both kilograms. Now we need to solve using these two masses. We need to interpolate it again, but for the 1585. Okay, so for 1585, what we're gonna do is we're just gonna do this, but instead of having this be inclination, it's gonna be altitude, and this is just gonna be mass, regular. So our altitude is between, our x high is 1650, right, because we're in between 1650 and 1500. Our x low is going to be 1500, and our x desired is 1585. Then our y high, remember, this is corresponding to whatever the altitude is, so that's going to be 1650 is going to be corresponding to the 1325.4, and the 1500 is the lower one, so the y low is going to be 1377.8, and we don't know this. So let's just do the formula again. We'll call this yd final, so it's going to be yh minus yl over xh minus xl times xd minus xl plus yl. And I'll write out this now since we have some space. So it's going to be equal to yh is 1325.4 minus 1377.8 over 1650 minus 1500. I'm running out of space. All right, we'll just squeeze it in. Then we'll do xd minus xl, which is 1585 minus 1500. We'll just simplify. We'll just say it's 85. We know. and then we'll add that to YL. 1377.8. So simplifying all that, what do we get? 1325.4 minus 1377.8 divided by 1650 minus 1500. Oops. 1500. Multiply that by 85 and add 1377.8. And our final answer is 1348. I'll just say 1. Fine, 1, 2. Okay? And that's in kilograms. So we did it. This is our answer for the linear interpolation of 1585 kilometers of altitude and 43 degrees of inclination. So hopefully you found this helpful, and you understand how to do this stuff now. If you're not gonna do this again and you're just watching for the interpolation stuff, hopefully for thermo or chem or data science or something, you understood what was happening. And yeah, I have nothing else to say. Thank you and goodbye.